Assalamualaikum and hello everyone. In this video, what we're going to learn is actually show Sn1 and Sn2 mechanism for a given haloalkane. In the previous video, we have explained what is Sn1 and Sn2 mechanism, and we have compared the relative reactivities of primary, secondary and tertiary haloalkane. So in this video, we're going to apply that knowledge for a given haloalkane. So let's look on your notes on page 7. So hydrolysis of haloalkane ni, so hydrolysis of haloalkane is actually your reaction. It could be with sodium hydroxide ataupun potassium hydroxide reflux, or it also can be done with H2O reflux. So how to determine which reagent? But then we should look for our question inilah example A, 2 bromo 2 metapropane. So kita dah belajar SN1, SN2 kan. So here is just summary. SN1 tertiary dengan weak nucleophile, which the presence of lone pair. SN2 methyl halide ataupun primary, which we're going to use strong nucleophile, which the presence of the negative charge. So for the case of our reagent here, so now ataupun koh ni sebenarnya Na plus OH minus. So OH minus tu, so it means that this one is for strong nucleophile, H2O is our weak nucleophile. So kita dah tahu dah ada summary. Let's look example A, 2 bromo 2 metapropane, we have 3 carbon, and pada carbon number 2 we have bromo and methyl. So make sure carbon cukup 4 bond. So yang lain tu cukup kan dengan hydrogen. So let's look here. So pada carbon yang contain Br ni, it's bonded to 1, 2, 3 carbon. So maknanya this is actually our tertiary haloalkane. So if tertiary haloalkane, it wants to undergo SN1 with our weak nucleophile. So I'm going to react it with H2O reflux. So H2O, and then reflux. So for this reaction to occur, what would happen is actually we're going to substitute OH to our halide. So our halogen. So bromine, I'm just going to remove it. So I'm going to add OH. So this is actually my reaction. But then how about the mechanism? So let's look for the mechanism for SN1. Step 1 adalah formation of carbocation. So formation of carbocation. So let's draw the structure of 2 bromo 2 metapropane dulu for our step 1. So I'm just going to label it. No need to mention the formation of carbocation. It's enough with step 1 only. So what we're going to do adalah break the bond. When we break the bond, electron will move to more electronegative atom, which is bromine. Bromine group 17, carbon group 14. So that's why electron will move towards bromine. So have to show lah from the bond itself towards bromine atom. So and then this bond breaking is a slow reaction. So our product, what would be our product? Remember, once the carbon has donated the electron, so the positively charged, and bromine, once it accepts electrons, so there's the presence of negatively charged. So we have already formed our carbocation. And Br minus is stable ion sebab actually it already achieve octet. Lepas tu, for formation of carbocation, we have to check the classification lah. Because actually we can do rearrangement. So kita tengok carbocation is actually tertiary. So it is the most stable. So there's no need for any rearrangement. So we can proceed with step 2. So step 2 is actually our nucleophilic attack. So nucleophilic attack ni, in this case, our nucleophile is actually H2O. So I'm going to draw the expanded version of H2O. So it's fine if you do not show the the lone pair, but we have to show electron to from oxygen to our carbocation, from the rich electron to the poor electron species. So this is a fast reaction. And then I'm just going to draw again the product. So what we have here adalah O ni is bonded to 2 of our hydrogen. But then oxygen already donate the electron. So they positively charged. Okay, carbon ni dia accept, so negatively charged, but itself ada positive, so cancel out the charge. Right now, kita nak form OH. We're going to remove this hydrogen. We're going to react it again with our nucleophile. Okay, so what will happen? Electron that akan move from the rich electron species, which is oxygen, to our hydrogen. Lepas tu, this bond will break. So, bila dia break, it will move to more electronegative atom. Sebab hydrogen group 1, oxygen group 16. So, we have to show the bond breaking from the electron to oxygen. Okay, so we have to show the arrow and then draw our product. Okay, so O ni dia akan bonded to hydrogen. Okay, and then so what happened? Okay, sebab dia dah accept electron, negatively charged, so dia dah neutral. Actually, that's our product lah. So, our H2O ni dah accept another hydrogen. So, sebenarnya dia jadi H3O+. Or this is actually the expanded structure. So, that is the mechanism for E. Okay, so step 1, make sure when we have carbocation ion, check for any rearrangement possibility. Okay, so now let's look for example B. Okay, so we have butane. Butane means that we have 4 carbon. And then pada carbon number 2 and 3 we have substituent. 2 we have chlorine, 4 we have methyl. So make sure each carbon we have 4 bond. Okay, so cukupkan dengan hydrogen. Okay, dalam case ni when we check, it's actually, so let's check here. Carbon ni is bonded to 2 carbon. So it's actually secondary haloalkane. Kita pergi sini nak tulis pula kan, sebenarnya SN1 prefer tertiary dengan secondary lah. Okay, so this is SN1, so the weak nucleophile. But then I want to do straight away the mechanism. So nak tengok ada rearrangement ke tidak. Okay, so what happened here? Again, first adalah formation of carbocation ion where the bond will break. Okay. The electron will move towards chlorine, which is more electronegative atom. So this reaction is a slow reaction. Okay, so this bond will break plus dengan Cl. Okay, sebenarnya Cl ataupun our halogen is a good leaving group. So that's why it could break by itself lah. Macam suddenly they break. Okay, again electron will move towards more electronegative atom. So accept negative charge. Kalau donate, positively charged. Okay, but then again, for the carbocation ion, always check for rearrangement. Okay, so kalau nak check for rearrangement, we have to classify lah each carbon. Okay, so kita akan classify tu next to carbocation ion je, jangan jauh-jauh. Okay, kita tengok carbocation ion kita secondary, sebenarnya primary. On the right hand side ni is tertiary carbon. So what happened here is that actually it could undergo rearrangement to form more stable carbocation ion. Sebenarnya boleh jadi tertiary carbocation ion. Okay, so kita akan pindah sebelah-sebelah ni. But what we're going to shift, so sekarang ni kita akan kata rearrangement ni 1,2 hydride shift ataupun 1,2 CH3 shift. So which one yang kita akan pilih? So priority kita adalah hydrogen dululah. We're going to shift positif tu dengan hydrogen shift. Okay. So, kat sini I'm going to write down 1,2 hydride shift. Okay, so what happened here, we're going to shift this position. So, sebab walaupun dia ada 2 pilihan, we're going to choose H dulu. Kalau tak ada hydrogen, baru CH3 shift. Okay, so I'm going to change the position. Okay, tapi yang ini a bit unclear kan? Okay. I want to change the position of H ni lah. Sebab pada yang second carbocation ion ni. Okay. So sini clear lagi lah nampak We're going to shift the position of positive charge dengan hydrogen. So, the green one ni yang ada hydrogen. Carbon yang green one ada hydrogen. Yang tertiary ni dah jadi carbocation ion. So, this is our tertiary carbocation ion, which is the most stable carbocation ion present. So, yang itulah yang paling boleh kita buat. So, barulah kita boleh buat step 2. So, again, make sure carbocation ion is the most stable. So, proceed with step 2. Okay, so I'm just going to copy paste it here. We're going to react it with water. Tapi for this time around, I don't want to do any expanded version. Okay, so we have to show the electron movement is actually from oxygen to the carbon, from the rich electron to poor electron species. So this is a fast reaction. But this time around, bila Miss dah nak bagi ni, when I'm gonna attack H2O ni, this time around I want to do the expanded, because nanti kita nak break the hydrogen bond kan. Okay, again, sebab oxygen dah donate electron, dia positively charged, carbon dia dah accept, so dah kira tak ada charge apa-apa lah. Okay, so right now what we're gonna do adalah we're gonna react it again with our nucleophile. Okay, so to form our alcohol. Oxygen will take hydrogen and this bond will break. This bond akan move to the more electronegative, which is oxygen group 16, hydrogen group 1. Okay, so what happened here is actually our product ni. So I'm gonna delete the positive charge dengan hydrogen. Okay, so what is left is H3O+. Okay, again, why? Oxygen dah donate electron, so adanya positively charged. Okay, lepas tu oxygen ni dah accept electron negatively charged dengan positively charged dah cancel out. Lagipun OH neutral. So we have discussed the example for the mechanism hydrolysis of haloalkane on page 7, where we have discussed the SN1 mechanism, where we have looked if there's no case of rearrangement and if there is rearrangement in our haloalkane. So that's it for the example on page 7.